Dylan, you just had a banana. We're going to solve right triangles. To solve a right triangle just means to find all the missing lengths, find the lengths of the sides, and all the missing angles. That should be fairly simple. To solve a right triangle, we need to know at least two things. We already know that one of the angles is 90 degrees. So if we have another angle besides that and a side length, then we can solve. So we could, if we know the non-90 degree angle and a side length, we will be able to solve. Or you could have a situation where you have two side lengths of the triangle and none of the other angles except for that 90 degree one, and you'd be able to solve. So I'll do a quick example. This is super easy. So example 1. Suppose we have this triangle. It says, well, we have two of the sides of the triangle, so we can actually figure out the rest of them. That's first by using Pythagorean Theorem. So I would get 8 squared plus 2 squared, and that'll equal, I'm going to call it C. That'll equal C squared. So that's what, 64 plus 4 is 68. That's C squared. So C, if I square root both sides, it would be the square root of 68, and I would simplify that 68. I'd do a factor tree. What is that? 2 times 34 divided by 2 again. What is this? 15, 16, 17? So, and that's a prime number. So this would be C equals 2 root 17, or approximately 8.2, if I round to 2 decimal places, 25. And I'd want you to get both. This is good to practice getting both. Both a decimal approximation and the exact values simplified as much as you can. But we are not done. We are not done with this because we need to have the other angles. The angles. I'm going to call that alpha and I'll call this beta. I still need to solve for those, right? Because solving means finding all of the values, right, Dylan? Dylan. I don't know. So, alpha, how do I do that? Well, I know that C is approximately 8.25. I'm going to say 2 root 17 because it's exact. And I can use my trig functions. I use SOHCAHTOA. So how would I do that? Well, I already know, I already know that I have exact values for my 2 legs of my triangle. So I'm going to say, I'm going to try and find alpha by using tangent. So tangent of alpha would be 2 over 8, right? Opposite over adjacent. So tangent of alpha equals opposite over adjacent, which means that's 1/4. So tangent of alpha equals 1/4. And in a calculator I would do this because 1/4 doesn't ever show up on the unit circle for the coordinates. So I could take the arctangent of both sides and it would give me, like, this is what I'm actually doing. Or the question here, remember, is what alpha, when I put it into tangent, gives me 1/4. So that's what I'm looking for, and I'm going to do that in my calculator. Make sure you're in degrees. I think it'll be simpler? I don't know. It'll be more understandable if you're in degrees. And I'll just do that in my calculator. So that's really what I'm doing. I'm just 1/4, that's 0.25, and then I'm doing arctangent or inverse tangent of that. And my alpha is approximately 14.0, if I round to 2 decimal places, 0.4 degrees. Alright, and I have one more thing to solve for. I just have my b value to solve for. So I'll do that. Oh, but here's something that's really super easy. Once you have one of the angles, it's a property of right triangles. Hold on. The last thing that I need is my beta. And I know from geometry that alpha plus beta plus that 90 degrees has to equal 180. Well, I already know this is 90, so what plus 90 gives you 180? 90. So these two angles have to add up to 90 degrees. So beta will be, I'll do that in green. Beta has to be 90 degrees minus 14.04 degrees. And that would be approximately 75.96 if I round to 2 decimal places. And I know that because alpha plus beta, the two non-right angles in the triangle, have to add up to 90. So there you go with that. Isn't that right, Dylan? Are you Dylan? So, yeah, do we have that? That's very nice. What else? Maybe a word problem? Maybe? No, that's all for now. That should be fine for now. This is a good day.